Okay, so we were dealing with cyclones, the dynamic portion of climatology, and we have seen they have an important role to play in Indian monsoon. That is a dynamic concept. We are studying it with a link with Indian geography, like Indian monsoon, right? So another links the dynamic concepts are western disturbances. We were dealing with cyclones, and cyclones we have completed one part of cyclone, that is known as tropical cyclone. And our cyclone, that is our monsoon, Indian monsoon, was largely affected by this particular cyclonic depressions, and that is very clearly visible this season itself. In the newspaper, cyclone monsoon advanced affect you have seen that. And a small portion of this tropical cyclone is remaining, and that is the comparison of this cyclone with respect to temperate cyclone, right? We have to compare two varieties of cyclones, what are tropical cyclones and what are temperate cyclones. So for that, we have to understand what is temperate cyclone. We have just started with the topic that is known as air masses in the last class. Is that clear? Air mass. Shall I take a small diversion? Yes. Topic cyclone right? You can just remember those particular things. That is cyclone and that is known as a low pressure cell, right? A localized low pressure cell. That is a cyclone. If I ask you what is anticyclone, just when I'm making the term cyclone, you must know what is anticyclone as well. So what is anticyclone? High pressure region. Okay, extratropical cyclone. No, not extratropical cyclone. No. High pressure zone with air where air descends. Yes, fine, good. Yes. So that perfect. The issue is it's a localized cell, right? Cyclone, we have discussed that we have two types of pressure zones, right? So one can be an elongated pressure zone, second can be a localized pressure zone. I hope yes. What is your localized pressure, elongated pressure zone? Can be a line like equatorial low pressure, right? It's a yes, equatorial low pressure belt or subtropical high pressure belt. These are elongated lines. Cyclonic depressions they are localized low pressure. So that is cyclones. Similarly, anticyclones are localized high pressure cells. That is the basic difference. You have to know that. Clear? That means the basic difference. Localized cyclone where the air rises. In a localized area where the air rises, what happens? The surrounding air gushes into in a rotating direction, and that is a cyclone. And the area where the air descends, that area, localized area, that area is referred as anticyclonic conditions. Clear? So please understand very clearly these two concepts. Anticyclonic conditions are associated with high pressure. So it is associated with high pressure. Clear? And the cyclonic conditions are associated with low pressure. So that difference, let it be very clear. So when you study the Indian climate, we generally say that during the dry winter season, dry winter December to March. During the dry winter season, the northern part of India, it has certain high pressure activities, that is high pressure anticyclonic conditions going on in the Indian landmass. So Indian landmass high pressure condition and the anticyclonic condition it is experiencing a high pressure location, right? So please remember this anticyclonic conditions. Clear? Now one more thing, you just have to if you have to draw these particular things anywhere or answer them, or if you need figure or something, so please make sure you can represent them. If it is better than writing, you mark them with some figures. So how you mark these figures? So if I draw some, you can just make a small chart. In that chart, one side you can write cyclones. You can write along with me. Okay, one side you can add. Okay, one side you can add cyclone. On the other side of column, you can write anticyclones. Clear? You can do this along with me. We don't have much time. So cyclone and anticyclone, these two things. Now, what you have to do is, first thing, how we represent this cyclone and anticyclones, and we will just write few differences. Now, if I want to represent it in the northern hemisphere, right? So first thing, I'm taking the case of northern hemisphere. So this area is my northern hemisphere, and here this is the southern hemisphere. And we all know that the cyclone in the northern hemisphere, it is in which direction? Clockwise, right? When I say clockwise, can I say it is represented like this? One minute. me add one more thing here. Just try to understand. Okay, this can be helpful for your for writing a better answer. So this is how cyclones are, right? This is how cyclones are. This various cells because different, these are isobaric lines, right? This can be, suppose the first line, the interior line, low pressure, it can be 997 or maybe 980 millibars. Line, it can be 1000 millibar, it can be 1010 millibar. That is only in the pressure increase. The inside one is the lowest pressure, and that is my low pressure. So how you represent this particular cyclonic conditions? This is my low pressure. There is no option to change color, I guess, right? Okay, leave it. So cyclonic depressions, we know that it is marked as it is marked in clockwise direction in the northern hemisphere. So this one, can I say this is clockwise rotation? This one, this one. So this is how cyclones are represented in the northern hemisphere. Okay, so this is just a representation, 2D standard representation. If you draw this particular thing, you don't have to explain much, because this is most acceptable representation for cyclones. This is in the northern hemisphere. So cyclone, it's a low pressure area, so air gushes into the system. That is what it is shown with Coriolis effect. Coriolis effect clockwise, anti-clockwise. I'm sorry. Northern hemisphere, last class northern hemisphere cyclone, it moves in anticyclonic conditions, and you can see this tendency of this anticyclonic rotation. Similarly, the opposite, what is high pressure condition? This is my high pressure situation. High pressure situation, anticyclonic condition will be directly opposite to the cyclone. Cyclone and the system moves into the low pressure area, and that low pressure area to anti-clockwise direction, because northern hemisphere cyclone is anti-clockwise direction. We have discussed that in the last class. Near opposite anticyclonic conditions, it is high pressure center. High pressure center in the air moves outwards, and the clockwise arning, this will be your, the anti-clockwise arning, this will be your clockwise direction. So this is how your anticyclones are represented in the northern hemisphere. So this is how anticyclones are represented in the northern hemisphere. So whenever you have to write a difference, please remember such figures can fetch you more marks if you get a technical question here. Clear? So this is how the representation: cyclone in northern hemisphere, anticyclone in northern hemisphere. Cyclone cyclone moves in anti-clockwise direction in the northern hemisphere. Anticyclone undangil, it moves in clockwise direction in the northern hemisphere. Cyclone, the air enters into the system. Anticyclone, the air moves out of the system. Yeah, this is how it is represented. And again, today's second homework, you will draw the figure for southern hemisphere and send it to me in the group. Okay, you can take a snap and send it to me. So homework send it, right? So that's how it is represented in the northern hemisphere. You have to draw it for the southern hemisphere. Yeah. Now I hope you have drawn this chart. One side is cyclone, one side is anticyclone. Differences that can be helpful. Differences. First difference here. Cyclonic conditions. The pressure center is the low pressure is too strong. The low pressure is too strong here. The low pressure is too strong. Bracket you can mention high pressure gradient. High pressure gradient. Here you can mention anticyclone low pressure gradient. Low pressure gradient. That is a strong pressure difference high pressure condition. Clear? That means it should be very much clear. If I compare on the second point, if I compare the wind speed, what can I say? Wind speed is high here, wind speed is low here. Make that your next point. Next point is wind speed. When the pressure gradient is higher, wind speed will be higher. So here you can mention higher wind speed. Here you can mention lower wind speed. 2 points. Higher wind speed, high wind speed, cyclone, anticyclone, lower wind speed. If I talk about temperature gradient, can I say temperature? Okay, leave it. No, temperature we cannot compare it much, so leave that point. You can mention next particular thing, cloudiness. You can mention the situation of cloudiness. Now, in this situation, in this area, cyclone is a low pressure system. So what can I say? It will be highly cloudy. Why? Because the air is rising. When air rises, it cools down, condenses. You will get cloudy situation here. Anticyclonic condition, please mention no cloud, or very little cloud, or you can indirectly mention clear sky. So here excessively cloudy, here anticyclonic condition, clear sky. Clear sky. Precipitation, next point. Precipitation you can mention, you know that cyclonic condition you have heavy precipitation, anticyclonic condition you have clear sky, so no precipitation. Clear sky, so no precipitation. Next, vertical air motion. Here the vertically the air rises, here the air falls. So you can make these differences, right? Simple sign, you know most of them. This here rises and here the air falls. And last point you can mention about the size. Now please, you can answer one point. If I talk about the cyclonic depression, size of this cyclone versus anticyclone. Now the southern hemisphere homework. I have removed that particular thing. Now my question is, if I talk about the size of these particular cells, which will be larger? Low pressure cell larger, or high pressure cell larger? I'm talking about the size of these two cells. Both are low pressure, both are localized cells. Okay, one is low pressure, second is high pressure. Please tell me which will be larger in size, low pressure or high pressure. You can text, you can message it here in the chat box, or you can answer. I repeat the question. Low pressure and high pressure cyclonic conditions and anticyclonic conditions difference. Now I'm adding one point here. The one point is, if I compare the size of low pressure cell versus high pressure cell, which is larger? Low pressure is larger, low pressure is larger, low pressure is larger, low pressure. Okay, 2-3 answer for another. Low pressure is larger. Is that so? Okay, think again. Any change? See, I'm not asking which is strength here, right? I'm just asking about the size. Size and the low pressure means a strong convergence takes place into this area. That is surrounding area to carry very one. So it will be restricted into a very small area, right? So size wise, it will be covering a small area because the air is converging into. But here what happens? It is moving outward. So when it is moving outward, naturally the size of the cell here, it will be larger. Clear? High pressure area, the air is moving outwards. When the air is moving outward, naturally the size is bigger in the case of anticyclone. That is, if I want to, suppose on the map of India, I'm very sorry for this map. So here, if this is India, I want to show somewhere here. So low pressure or high pressure, compare, if I have to compare, low pressure can be generally shown as a very small system. But high pressure system, it will be generally a larger area. It will cover a larger area. Why? Because the air is moving outward, so it is covering more area. Please remember this. Generally, we tendency we just mentioned that low pressure is much more stronger compared to pressure gradient here is much more compared to here. But when I compare the size, please remember size of high pressure cell is larger than this one. Please don't make mistake in that case. I hope that is clear, right? 1 minute. So I hope that is clear, right? Shall I move further? So this is a point add cheyanadu. Anticyclone ne kurichu kariyayittu parannilla. Appo endelu statement wise questions vannu kazhinja prelims level you can get confused. So that's why I just added this particular point. Hope it's comfortable. Shall I move further? Please give me 1 minute, okay? Sorry. Yes. So hope that is clear. Yes or no? Shall I move further? Okay. Comfortable? Shall I continue with air mass? Okay. So we were dealing with air mass, right? So air mass and the last class we have written a few lines there. So air mass and air mass, I have mentioned that air mass is type of property that is attributed to air column, right? It is air column. Air column the air column which is stagnant over a landmass, right? The air column which is stagnant over a landmass. Such landmass this landmass should be relatively a flat land. Flat land over area basically the best formed air mass will be over the ocean. Why? Because it's a continuous flat surface. That's why land chances in which areas where you have a extensive plain area, you will have an extensive large plateau area. Generally, they are not formed in the mountains. Clear? Why mountains form? The reason is mountainous area you don't get a stagnant air; it continuously keeps on moving. So that was air mass. So air mass നമ്മൾ എന്തൊക്കെയാണ് consider ചെയ്യുന്നത്? I mentioned we have to consider two things. First is the temperature of air column. Second is the amount of moisture present in the air column. Third thing, in which area we are going to compare these things in a horizontal plane. This much thing you have to remember, right? With respect to air mass, എന്തൊക്കെയാണ് ഒരു stagnant area മേളിൽ develop ആവുന്നതാണ്. Horizontal surface le compare ചെയ്യുമ്പോൾ it has same temperature and similar temperature and similar moisture content. But if you move higher and higher, it can vary. Clear? And one more thing we have mentioned, it is generally developed in those areas where the air is stagnant. Where the air is stagnant means it is generally associated with high pressure. High pressure evideയാണ് subtropical belt lo polar region lo. So these are the two areas where you have this development of air masses. Clear? And I hope we have seen some type of air masses as well in the slides. So we have mentioned these types of air masses. You can see here, this is continental Arctic area, continental polar, maritime because it is in the ocean, maritime because it's in the ocean. This is polar air called this air mass. This is tropical air mass. So we have mentioned about this particular different types of air masses. Yeah, and now we are going to enter into our main area, that is temperate cyclone. നമുക്ക് മനസ്സിലാക്കാം. Temperate cyclone മനസ്സിലാക്കണമെങ്കിൽ you have to understand the interaction between the air mass. What is air masses interaction? So interaction means you can see in this area, suppose I am considering these two different air masses. How can these two different air masses interact? For example, this one you can see, this is continental polar air mass. Sorry. And this one you can see, this is continental tropical air mass. If I say these two air masses has to interact, clear? Now your heading should be front. Okay, your heading is front, FRONT. Front is your heading. Now front front means the boundary at which different air masses interact. This is one air mass, this is one air mass, or I can say this is one air mass, this is another air mass. The two air mass interact. Suppose this is an air mass, this is an air mass. These two air mass interact in our boundary. That boundary is known as front. Now how are front formed? What is the reason for the development of front? I can say, why do these air masses interact? Clear? The answer is very simple. They interact because of the prevailing wind existing in that area. For example, suppose I can say somewhere here I have the westerlies wind blowing in, and somewhere here I can say the polar easterlies wind blowing in. As a result, what happens? These polar easterlies wind will carry these particular air masses from eastern sides to western side. Right? This side in the air mass gradually to move. Similarly, east side westerly wind and the air mass it can gradually move into this particular direction. So what happens? They can meet somewhere here. So why these air masses move? The air masses are a localized area feature, but or you can see a global scale they lie in a belt where you have permanent or prevailing wind. A prevailing wind move and the air mass move. And air masses, when they move, they can interact among each other. And when they interact, they develop something known as the formation of front. Front is the boundary between two different types of air masses. And we have to study now different types of front. Is that clear? Now, just write two terms, right? We will just understand these two terms, then we will take type of fronts. So two terms will be front and the first thing front and just one liner you can write. What is a front? A front is a sloping boundary. A front is a sloping boundary surface. A front is a sloping boundary surface formed due to convergence of two drastically different air masses. Formed due to convergence of two drastically different air masses. Please underline drastically different. Same type of air mass all interact in, different types of air mass are interact in, then only you will get front. We have studied somewhere that equatorial low pressure belt mentioned equatorial low pressure you have two easterlies wind converge into that area. Easterlies wind converges that they collide themselves and rise, but our front form cheyunnilla. The reason was their temperature, moisture, all the properties were similar. So please remember, front develop the air mass should be of adiabatic. Sorry, the air mass should be of drastically different type of properties. That can be with respect to temperature, that should be with respect to humidity as well. Clear? Okay. Next, I said we will be dealing with 2 points, two words here. What are these 2 words? The first word you can mention, it is frontogenesis. The first word you can mention, it is frontogenesis, and the second word you can mention, frontolysis. So please understand 2 words clearly. One is frontogenesis, second is frontolysis. Clear? Frontogenesis no the meaning genesis meaning in it is origin. So what is frontogenesis? It is origin of a front, it is formation of a front. That's frontogenesis. So frontogenesis. What is frontogenesis? It is formation of a front, that is known as frontogenesis. Okay, so Amrita, current word, did you miss anything? I hope no, right? So we are just mentioning about this front in the formations, drastically two different type of air masses. They collide themselves and form a front. Clear? Okay. Now we are discussing 2 words. One is known as frontogenesis. Second is known as frontolysis. What is frontogenesis? Two air masses, they come together, collide and form a front. That is frontogenesis. What is frontolysis? The opposite of frontogenesis. That is dissipation or decay of a front is known as frontolysis. Or a front dissipate how it disappeared. Or a front boundary or separation exists. There are some conditions which generate because of which it will gradually dissipate away. The front will not appear continuously. That dissipation is basically referred as this particular thing is frontolysis. Yeah, so 2 things we have understood. One is frontogenesis, which is known as origin of this front, or the beginning of front, or frontolysis. It is dissipation of a front. So please understand this particular thing. Now we are going to understand different types of front. Now you're heading types of front. Types of front. So we will be discussing 4 types of fronts here. So please understand them very well. I will give you to write, right? So no need to write. I will just give some important points that you should write. So please understand them clearly. We are discussing 4 types of fronts here. First is known as cold front. Second is warm front. Third is occluded front. And fourth is stationary front. I repeat, we will be dealing with 4 types of fronts here. Either 4 types of fronts. One will be warm front, second will be cold front, third will be stationary front, and the fourth will be occluded front. So let's see what are these different types of fronts. So what is cold front? What is a front? First thing you remember, front and then 2 air masses interact in a salam. Now if I say cold front is a boundary where a cold air and warm air meet. Warm front is also a boundary where warm air and cold air meets. But what is the difference? If you ask me, the difference is, see, when I talk about 2 fronts, right? Suppose I hope you can see me, right? Everybody, yes. So here, suppose this is a cold air and this is a warm air. These are 2 different air masses. Now, based on the prevailing wind blowing over this region, there can be some time that this wind, it is moving faster. This air mass moves faster. Or suppose because of the wind here, this air mass move faster. You have to consider which one is moving faster, this one or this one. Which is moving faster, we will name the front accordingly. I repeat, this is suppose cold air mass. This is suppose warm air mass. So I have 2 air masses. Now suppose the wind blowing over this area is faster. So what happens? The cold air mass will move faster and will go and hit the warm air mass because the wind was faster this side. Yeah. So air masses. Suppose I am considering this air mass. Can you see this continental tropical air mass? This one. Slide right? This air mass. Now, suppose I am talking about a wind pattern in this area. Suppose it is westerlies here. It is a tropical belt, basically easterlies. Suppose I am just considering a hypothetical situation. Suppose you have a westerly wind blows in. What will happen? With respect to this westerly wind, this air mass will be carried towards this direction. Yes or no? Similarly, I'm talking about suppose this direction. Suppose you have a wind coming from this direction. I'm just talking about hypothetical situation again. Suppose a wind is blowing in this direction. What will happen? This air mass along with this wind will be carried towards this direction. So you have to see which air is moving, right? Which air mass is moving. These are two air mass, cold one, warm one. This cold one is more active. That is, this cold air mass is moving towards warm and hitting to it. So this is more active. So you will name the front accordingly. This will be known as cold front. If the warm front is moving actively and hitting the cold air mass, it will be known as warm front. So we have two types of front. Cold front, the cold air mass is more actively moving and hitting towards the warm air mass. What is warm front? Warm air mass is more actively moving and moving towards the cold air mass and hitting it. Clear? These are two types of fronts. Now, what are the differences among these particular types? What can be the difference? So let's understand it with this slide. You can see here, the first example is of cold front. Cold front this one, this blue color shade cold air, and e case warm air. Now, can I say one thing? Whichever may be the situation, that is, I have mentioned a condition of formation of cold front and the formation of warm front. Two condition cold air fast to move warm air fast to move. Now, whichever should may be the condition, which will be the air that is rising? Please tell me, you can answer it. Which will be the air that should rise? Cold front, which air will rise? Warm air or cold air? Warm front, which air will rise? Warm air or cold air? Warm. Yes. So that is very clear. So whichever may be the situation, the air rising will be the warm air because warmer is lighter. Clear? So if you know that, now in this case, the cold air is relatively compressed, right? Cold is compressed, warm air is expanded state. So when it is compressed, this air in the surface, cold air when it pushes it, it will relatively get steeply converge. You can see it here. I will just show you here. You can see the difference and you can understand. See here, this is when I'm saying it is a warm front. Here, warm front is pushing the cold air, right? Warm air is pushing the cold front. Cold front to cold air was already compressed, and warm air when it pushes it further, it will get more compressed. As a result, this will be more steeper. See the difference here. This is the difference that I want to see. Now, in this situation, you can see this was a warm air. Here, you can see it is a cold air. Now, front in the name you can say. This one is, you can see it is a cold front. What is a cold front? The cold air is more active. So when I say cold air is more active, can I say this blue color is moving towards this direction and colliding with the warm air? And when it collides with the warm air, it cannot compress this particular warm air. And when it cannot compress this warm air, this area you will relatively get steeper surface because this side air is not getting compressed. But here you can say this is a cold air. This is a cold air mass, and this cold air mass is being pushed by the warm air mass. Why? Because it is a warm front, right? Warm front, warm air, cold air ne push cheyana. This cold air was already compressed. Push it will get compressed further. As the result, you can see this gradient. This is development of front. It will be very gentle in this case. So please remember, this is the difference here. So what is the difference? Cold front formation, the front will be very much steeper. Clear? Why? Because warm air cannot, because cold air is pushing. Cold air is not being pushed. If in this case, warm air would be, if suppose warm air would have been pushing the cold air, then you would have got this situation. But here, cold air is moving into this direction. That's why you are getting steep slope in this area. But here, warm air is pushing the cold surface. As a result, cold surface gets compressed further. As a result, you get a slanting surface. So is this clear? That is the shape of these two fronts. Is this clear? The conclusion is cold front is steeper with respect to slope. Warm front is gentler with respect to its slope. Is this clear, everyone? Is there any doubt? The shapes of the front. Okay, right? Yes. Okay, let's move further then. Now, Please tell me which area will receive more rainfall, warm front or cold front. You have the figure in front of you. You can infer from it, or you can tell you use your own logic, which area receives more rainfall, which area can receive more rainfall. It is a warm front, it is a cold front. So please answer which area can receive more rainfall. Yes, Padmans. The area covered in the cold front will be lesser, and the area, I will explain it again. You will understand it. Please wait. Okay. Now please answer which area will get more rainfall, cold front or warm front. Cold front, warm front. Rand answer. Anybody else? If anybody didn't get this particular thing, I can repeat. If you have any doubt, you can post it here. Okay. Warm front, warm front, warm front. Okay. So most of you are with warm front. Now let's please understand here. You cannot answer directly here, right? What is the question? I asked which area receives more rainfall, right? See, both areas receives rainfall. You can see here. Why you are receiving rainfall? Because which is the air column which is lifted here? The warm air column lifted, right? This warm air column got lifted. Both the cases, warm air column got lifted. And when the warm air column got lifted, it gradually cools down with height, resulting in condensation and rainfall. But in this case, what happens? The warm air mass, it rises more steeply. In this case, what happens? The air column, air mass, it rises gently. Yes or no? It rises steeply here. It rises gently here. And you remember, we have studied different types of clouds. The clouds which are spread along a huge area, which cover a huge area. Remember, those are known as stratus clouds, right? They form flat layers. Those are stratus clouds. Because it covers, it's a very gentle slope, they are stratus clouds. And in this case, as the rising is very sudden, can I say it can be comparable with our cyclonic cloud formations? In other words, can I say convectional rise ഉണ്ടാകുന്ന സമയത്ത് localized area in the air rises very fast? Or in other words, if I say orographic topography, mountains ഉള്ള സ്ഥലത്ത്, orographic rise ഉള്ള സ്ഥലത്ത്, the cloud continuous formations ഉണ്ടാകും in a localized area. As a result, why? Because air steeply rise in a single area. Similarly, here also you can see the air is steeply rising in a single area. As a result, you will get rainfall here as well. Now, please remember, there will be a different types of rainfall in this area. And what is that difference? Here, as the formation is cumulonimbus cloud, you will get relatively very heavy rainfalls heavy rainfall in this area. It can be associated with thunderstorms as well. You will get very strong, very heavy rainfall in this area. Here you will have rainfall, but it will be moderate or light showers. It will not be very heavy rainfall. Because cloud is distributed. Yeah. So what is the answer? The answer is both the area receives rainfall, but this cold area, cold front, where you have localized rising, receives very heavy rainfall, while the warm front receives relatively lighter or moderately heavy rainfall. But there is a difference with respect to time. Can I say this area will receive rainfall for more duration, while this area will receive rainfall for short duration? Because what happens is cloud formation you will get a very strong cumulonimbus cloud and will lead to a very fast and very strong rainfall in the very small amount of time. But this will result in very means well distributed rainfall over a huge area and a huge time period. That is the basic difference. So please remember, ഈ രണ്ട് ഫ്രണ്ട് തമ്മിൽ റെയിൻ ഷേപ്പിൽ വ്യത്യാസം വരുന്നതിനനുസരിച്ച് എന്താ വരുന്നത്? ടൈപ്പ് ഓഫ് റെയിൻഫോളിൽ വ്യത്യാസം ഉണ്ടാകുന്നു. What is that type of rainfall വ്യത്യാസം? Here you are getting rainfall in a very small area, very localized area. And you can remember one thing, localized area മാത്രമല്ല, ഈ localized area തന്നെ you get very strong rainfall. Here rainfall is well distributed. You get rainfall over a very long area, and it will be moderate to light shower. It will not be very heavy rainfall. That is the basic difference between these two types of fronts. When I discuss these two things, whenever you draw figures, these figures you can use in the exam, no issue. But please remember, technically when we talk about this subject, we use certain symbol for them, and you have to know those symbols. They are very important, right? So what are these symbols? Please understand, the warm front, it is marked like sorry, it is represented like this: a straight line and curved shapes on this side. Okay, so this is they're not pointed. These are curved shapes. This is how generally a warm front is represented. And if you want to represent a cold front, it is same straight line, but instead of this rounded face, it will be sharp ends here. It will be sharp ends here. So this is how cold fronts are represented. You have to remember the shape. The shapes are technically well accredited terms, right? It is globally accepted way to draw this. So this is how warm front is represented. This is how cold front is represented. I will show the slides, but remember, this is how it is represented. Yes, see this one. This is your, I said, cold front. You have sharp ends. So this is how your cold fronts are represented, and this is how your warm fronts are represented. Clear? That is representation. So these are first two types: cold front and warm front. Now the third type of front is known as stationary front. What is stationary front? What was our front till now? Right? The front was, this was an air column. This was another air column. The air column, when they meet, that area, that is this area, was known as front. Yes or no? Suppose this is a cold air. If this was more active, we would call it as cold front. If this is a warm area, and suppose if warm air is more actively colliding into the cold air, we would call it warm air front. Suppose these two air masses, they don't collide. Suppose these are two air masses, they are not moving towards each other. They are touching together. They have this touching. They are touching with each other. Here you can say they are touching with each other. This is a cold air mass, and suppose this is a warm air mass, and they are standing side by side. But nobody is moving. Neither this is moving towards this side, neither this is moving towards this side. Both the movement is not there. Both the movement is not there. That is, cold air mass is stagnant here, warm air mass is stagnant here, but they both are touching with each other. Such front is known as stationary front. Such front is referred as stationary front. There they are just touching each other. I will show you the symbol. Wait. So this is stationary front. Second is known as, fourth is known as occluded front, right? OCCLUDED, occluded front. What is occluded front means? See, suppose, how can I show you? Okay, let's see. Occlusion means a cold air mass, it overtakes the warm air mass. For example, suppose this is my somewhere near subpolar low pressure belt. It's a subpolar low pressure belt. Clear? Can you tell me the air temperature in the two areas? Can I say this one? The northern side is polar air, which is very cold, and the southern side, it is subtropical or temperate air, which is relatively warmer. Yes, cold air and relatively warmer. These are two different types of air masses. So if they are not moving in this direction, they're just touching with each other, we'll call this as a stationary front. Now suppose the air starts pushing from this side. This side in the air strong to push here. See, why does the air pushes? Here, the area here, it is very cold. Very cold means the air in this area will become very dense. If the air will become very dense, it will naturally push into this direction. If it push into this direction, when will it push strongly? Can I say during winter, this cold will become very strong and it will push into this side. So when it pushed this side, can I say the front developed in this area will be referred as cold front, because cold air is pushing into the warmer area. I hope it's clear, right? So what is happening here? So please here, I repeat. And then one more chart. Yes, I will repeat. Yes. So I'm explaining occluded front. Please understand the meaning of occlusion. Occlusion means the cold air mass completely lifts the warm air mass. Because see, രണ്ട് air mass തമ്മിൽ push ചെയ്തുകൊണ്ടിരിക്കുകയായിരുന്നു. push ചെയ്ത് when the warm air completely gets lifted, that situation is known as your occlusion, അല്ലെങ്കിൽ occluded front. I repeat, what is occluded front? There was a cold front, there was a warm front, whatever you have different types of front. In this front, when the warm air completely gets lifted up, that situation is known as occlusion or occluded front. I'm just giving you an example here how it is formed. This example will help us in understanding cyclone as well. So let's try to understand it much better. Suppose I'm talking about a pressure belt, whichever may be, leave the area, whichever may be. And we know this is the southern side, this is the northern side. And definitely you know that northern side will have cold air and southern side will have warm air. Yes, and we know that these air columns, the pressure lines we have already studied. Remember, equatorial low pressure, subtropical high pressure, subpolar low pressure, and we have studied the practical situation. They are not straight lines, they are haphazard zigzag lines. They are continuously moving with respect to differential heating. That is what I am explaining it here. Suppose this was the initial condition, ideal condition, where the line was flat. But suppose this side it becomes very cold and the air becomes very dense and it starts pushing towards this side. What happens here? If it starts pushing towards this side, this front will start moving towards this side. So which is this front? This is cold front. Why? Because the colder air is pushing towards the warmer surface. So this will become a cold front. So no, so this will become a cold front. Okay, so after some time, see, this is continuously pushing. Cold front is, this front is moving towards this side gradually. So after some time, can I say this front will reach here? Because the air is continuously pushing there. After again it is pushing here, the air mass downwards, it will reach here. So and suppose in this area, the air column, this is your warm air. When this air pushes this side, can I say the air left over here, it will be pushing into this side. Now this side it's a warm air, so warm front, this is my warm front. Clear? Now which one is moving here faster? See, cold air is denser, so cold always moves faster. The cold air is pushing this particular warm air into this side, and warm air you're getting two fronts simultaneously here. See, this side you are getting cold front and this side you are getting warm front. I will just explain it with this slide as well. You can just see it here. Please check it here. Remember this figure. But you are getting two fronts simultaneously. See, in between you are having a warm air, but a cold front on there. Cold front is pushing the warm air. Warm air warm air. Both the case, the warm air is getting uplifted. Clear? What is occlusion? I said the entire warm air gets uplifted, right? Let's see if I have a slide or not. Yes, you can see here. See, this was my warm front, this was my cold front. When as a result of continuous pushing, if entire warm air get pushed upwards and two cold mass will come together with each other, they will interact and they will mix up. So warm air entirely lifted up. This is known as occlusion or occluded front. Now I repeat it here. See, this cold air is pushing towards this side. It is gradually lifting the warm air. So gradually it will reach here. After that it will reach here. Finally it will just climb here. So when it climbs here, the warm air will remain here. So that is warm air entirely lifted up from the ground. Ground in the ground warm air illa. Ground air warm air this two cold air will mix with each other. Such condition is known as occlusion. Is that clear? I have to explain it further, but is that clear till now? You have any doubt till now? Answer me please. Okay, repeat. Yes. There is different types of air masses are interacting, right? So explain. So for example, let me draw again. Please understand these things very well. In the last class I mentioned this temperate cyclones. It will be very difficult to understand if you don't understand the class, because nowhere it is mentioned well in the textbooks and internet also it is confusing. So suppose I'm mentioning about this area, which is my earth surface. Yeah. Suppose here I have drawn a latitude and I'm considering this latitude now. This latitude explain. And when we have explained these latitudes, along these pressure belts, you might remember that we said the practical case, the pressure belts are not straight lines, they are having ups and downs. Clear? They continuously move like this. Now, what does this movement mean? This movement means, can I say, you can see this area, I'm just shading it, you can see this area. Can I say this zigzag movement results in downward shift of cold air? Ideally, cold air is straight line, but because of this zigzag movement, the cold air is coming till here. And here you can see, ideally, this should have been the region up to which the warm air should have come. So this is the warm air, this is the cold air. So this is the straight line up to which warm air should have come. But because of this zigzag pattern of the air, warm air is pushing towards this side. Warm air is entering into the colder region. I hope that is clear. So what is this? Can I say warm air is pushing the cold air? When warm air is pushing the cold air, I call it warm front. I call it warm front. Here you can see, when cold air is pushing into the warm air, I call it cold front. I call it cold front. Now, what remains between these two? What remains between this cold front and this warm front? This is this region. Can I say this region is full of warm air now? This air is gradually pushing towards this direction. That is, this front after some time will reach here. If it pushes further, this front after some time will reach here. So what is happening actually? This cold area is getting pushed into the warm area. As a result of that, the warm air is gradually keeping rising in this area, and it is pushing into this area as well. So two things are going on simultaneously. The warm air is rising as well as the warm air is getting pushed into this area. But you can see it clearly. What happens is, this was my cold front, this is my warm front, but cold front moves faster as the air is more denser. So what happens is, this area gets gradually narrower. So I want to show it in a bigger figure here. This is my, suppose it is a midline, this is my western side, this is my eastern side. Western side is this one. Western side, cold air is pushing towards the warm area. Clear? So I am getting, the front was cold front in this area. So this was cold front in this area. This was cold front in this area. Here, this is my eastern side. The warm air is pushing towards the cold area. So what was the front in this side? This was the warm front. This was the warm front. Yes or no? But which is faster? Cold front is faster. So when I say cold front is faster, can I say after some time the front will reach here? After some time the front will reach here. After some time the front will reach here. Then this front will reach here. Yes, of course, this front is also moving like this, but it is very slow. So when it is slow, gradually a time will come when this line will merge up with this line. That is, entire warm air gets lifted. And now please understand the same thing with this slide. You can relate and understand. Here, but this is the situation. This was my cold front. This cold front I figure left side. Remember, left side air push that is my cold front. Eastern side as a result, the warm air is getting pushed into the cold area, so I am getting a warm front. This two front both the fronts, see, cold air is pushing, cold air is entering into this area. So when this cold air is entering into this area, warm air is getting pushed, right? Here also, warm air is getting pushed to above the cold air. So what happens? Eventually, as this cold air, right? This is my cold air. As this cold air moves towards this direction, can I say warm air is gradually getting lifted? Remember this figure, okay? Just take a print of this figure in your mind now. It's a cold front, it's a warm front. I'm going to draw it. Take a print of this, right? Remember, this is a cold front. In between, you have a warm air trapped, and this is a cold front. Try to understand it here. So what was that figure? So what was that figure? This side, I had a cold front. This side, I had a warm front. Yes or no? What was happening? Cold front and cold air is pushing towards the warm air. Warm front and warm air is pushing towards the cold air. So what does this mean? Cold air is pushing towards this side means, can I say the cold air mass will reach here after some time? It will reach here after some time. It will reach here after some time. So what does this mean? So when it reached here, can you see, even in the warm air, it is just left in this much area now. And this area is off the ground. See, ground ഇവിടെ ഇത് ഗ്രൗണ്ടിൽ നിന്ന് ഈ ഫ്രണ്ട് ഇങ്ങോട്ട് നീങ്ങി വന്നപ്പം entire warm air is lifted off the ground. So it is free from the ground. There is no connection with the ground now. There is no connection with the ground. The entire warm air is lifted by the cold fronts. Such front is known as, when the entire warm front is lifted, this front is known as occluded front. Please tell me, is this clear now? From here we will try to understand cyclone, and if you understand this, cyclone is this temperate cyclone is very clear. Please tell me, is there any doubt? If you have doubt, please you can say. Padman's doubt Mario. Padman's repeat doubt Mario. Is it clear? Four types of front I will discuss here. There are four types of fronts discuss here. One is warm front. Warm front lendana, warm air is more active, pushing towards the colder air. Second front, cold front. Cold air is more active, pushing towards the warm front, warm air. What is the difference? Cold front is steeper, warm front is gentler. Next thing we have mentioned, that was a stationary front, and that means stationary front, two air masses, they lie side by side, they don't push each other. That is stationary front. So let's see stationary front somewhere here. This is stationary front. You can say this is cold air here, and this is warm air here. They're just touching each other. Nobody is pushing nobody. No one is pushing right against each other. So simply this is known as stationary front. Clear? Now what is occlusion? You can see here occluded front. And then e cold air move ingottu vannu, and it completely lifted off the warm air from the ground, and that is my occluded front. And please remember, these are the shapes. You have to draw these shapes. They are technically accepted shapes. So you have to draw. This is generalized shapes. Cold front nammal varachu kazhinju, warm front nammal varachu kazhinju. What is stationary front? Random mutti nikkuva. So you can see here, one side you have cold air, another side you have warm air. So just you have to show it in two sides, right? One side lo cold air kanikka, one side warm air front kanikka. That is your stationary front. What is occlusion? Mixed up. Warm air is completely gone in between the cold front. That is your occluded front. These are standard shapes you have to remember. Clear? So if you get a question, you have to represent them with this particular figure. Cold front, you have to represent them with this symbol, warm front, this symbol, stationary front, and occluded. I hope that is clear. See, these are again same thing. This is my cold front, this is my warm front, this is my stationary front, and this is my occluded front. You have the figures here. See, cold front, it is much steeper. It is not that clear figure. Leave this figure. Clear? Same thing. You can see here, this is my cold front, which is very steep. This is my warm front, which is relatively gentler. Clear? See, this is my occluded front. You can see it very clearly here. Warm air, see direction of the frontal movement. This front was moving from this side. It reached here and completely lifted the warm air. Clear? As a result, you are getting occlusion. This is my occluded front. Again, same thing, four symbols. Here we will discuss about cyclones. Okay. Now please write down a few things. Okay. First point, warm front. I'm just giving you some important points that can be helpful. Right, warm front. I hope you have drawn the figure. After warm front, you can draw this figure. This figure. And one more thing you can show in warm front. What is that? You can show a gentler air column. This you can draw this side. What is this? Warm air collides with cold air, and you get a very gentle slope. This much you can, this two figure you can draw. This is gentle slope, and second thing, the symbol. These two things you can draw. Warm front. Then you can write here the warm air mass. Here the warm air mass is more actively encroaching. Into the area of cold air mass. So we get gently sloping front. So we get gently sloping front. So we get gently sloping front. Next point, results in stratus clouds. results in stratus clouds. Stratus cloud, you remember, it's a flat spread cloud, right? So results in stratus clouds leading to moderate to light, light to moderate rainfall, leading to light to moderate rainfall, light to moderate rainfall. And star mark, you can remember one thing, write one thing, almost entire rainfall occurs in the colder region. Almost entire rainfall occurs in the colder region. Can you see it here? Cloud formation evade undavunne ee cold region de melilana ivide undavuka. When I say the cold region de melilanaengil, what happens? Ee warm area alla mala peyunu. This is my warm area ground il. So ground il evade mala peyune? Cold area nathana entire rainfall you are experiencing. So entire rainfall you experience in the colder region. Entire rainfall you experience in the colder rainfall. So can I say this leads to snowfall allengil foggy situations? Clear? So e location like nalla reethil fog develop avum. So whenever you have such type of development of front, warm front okke vannu kazhinja, entire precipitation is taking place in the colder surface, so you can get development of fog in this belt. So ivide fogum chela samayil ആ ടൈമിൽ സ്നോഫോളും ഇതെല്ലാം എക്സ്പീരിയൻസ് ചെയ്യാൻ പറ്റുന്ന കണ്ടീഷൻസ് ആണ്. So you get fog in this area. You have to remember this much point. Then shall I move into the warm front? So എന്തൊക്കെ ഓർത്തിരിക്കണ്ടേ? Shape, right? Symbol, remember the symbol, I have drawn it. Then type of cloud, type of rainfall, fog in this area. This much area thing you have to remember with respect to warm front. Okay, shall I move into the cold front? Cold front. Cold front. So here cold air mass is more actively, here the cold air mass is more actively undercutting into the warm air mass region. Undercutting into the warm air mass region. The slopes are steeper. The slopes are steeper. The slopes are steeper. These are associated with cumulonimbus cloud formations. These can be, yes, this can be better. This can be associated with cumulonimbus cloud formations. That is, remember cumulus variety. What is cumulus variety? Cauliflower bole, bubbles bole, that is associated with cumulus clouds, cumulonimbus clouds. You can mention. So associated with cumulonimbus cloud formations. Rainfall will be heavy to very heavy. Rainfall will be heavy to very heavy. Heavy to very heavy. And please write one thing here. Here star mark ediko. This figure does not show it correctly, but please write in star marks. Here majority of rainfall occurs in the warmer surface. Karna ivda cloud ningal onnu aalichu nokka. The air is steeply rising. So ee side lu matramalla ithrayum area la full cloud undav. Full this area you will get cloud. So when I say full this area you have cloud, rainfall will be in this area as well. So please remember, majority of rainfall in this case happens in the warmer air. Majority of rainfall in this condition happens in the warmer air. I'm not saying that there is no rainfall in the cold area. There is rainfall in the cold area, but majority of rainfall is experienced in this particular belt, that is warm air. Because cloud itrayum area matramalla restricted avva, ivide ellam cloud varum. So ivide ellam cloud varumbo naturally you get more rainfall in this area. So clear cut difference should be, the difference should be very clear. Warm front evadeyarnu mala kodilum peyunnathu, it is in the colder air region larnu peyunnathu. Warm front il rendadathu maliyundu, but majority of rainfall will be in the warmer air column. So don't forget that. And again continue here. As the weather pattern is more intense here, as the weather pattern is more intense here, this is associated with thunderstorms. This is associated with thunderstorms. Nan edine kuricha parayna cold front. As you have cumulonimbus cloud, you can get thunderstorms. So chances of thunderstorms are higher in this area. And you might have remembered these cold front frontal activity is very much famous in the temperate belt. So ningal US le evideyum kettirundo ennu enikkariyilla, regularly rain varuna pala sthalangalundu, sudden rain varuna sthalangal. And please remember, these one more point you can add, these areas are associated with sudden rainfall. Ivide nokka mala pedukke vannu continues for longer duration. Here it suddenly comes and you get heavy rainfall. So these are relatively cold fronts are associated with sudden rainfall, and this is not that sudden, it's a prolonged rainfall. This one warm front. So cold front, you remember sudden rainfall. Now you can add one more point. US ingante kore സ്ഥലങ്ങളുണ്ട് where you get very heavy rainfall due to this cold front formation. In such areas, they generally call it squall line. Squall, SQUALL. You can mention squall line, SQUALL. So those cold front areas in US where you have very sudden and strong rainfall, such areas are referred as squall line in US. Squall line. So squall line ini ennalu news nath kekkuvanengil, remember it is those areas where you are getting thunderstorms and heavy rainfall in the US. Such areas are associated with tornadoes. You might have heard about tornadoes. We will study this. Clear? So ee areas like namakku tornadoes um കാര്യങ്ങളൊക്കെ കാണാനുള്ള chances കിട്ടാറുണ്ട്. So please remember this particular thing. Clear? I'll just give you one more figure here. So these areas are best explained with respect to figure and symbols. Now if I want to show a symbol and a cloud association in this area, നിങ്ങൾക്ക് ഓർമ്മയുണ്ടോ ഈ ലൈൻ എങ്ങനെയായിരുന്നു initially? This was the line, right? ഈ ലൈനിൽ വെസ്റ്റേൺ സൈഡിൽ എന്തായിരുന്നു നമ്മൾ കണ്ടേ? വെസ്റ്റേൺ സൈഡിൽ we have seen, western side was having cold front, remember. Eastern side was having warm front. We have drawn this. So after some time it became like this. എന്തുകൊണ്ട് ഇങ്ങനെ ആയത്? Because this cold air was moving faster, so ഇത് bend ആയിട്ട് ഇവിടെ എത്തി front. So this area reduced. So here this is my cold front, this is my cold front, and this is my warm front. Now suppose my question is, you are getting these two fronts develop over some land or some water, wherever. Clear? I am checking it from this satellite and you are trying to draw the cloud above this area. Please tell me which area will have extensive development of cloud. When I mean extensive development of cloud, I am saying about broader cloud. Which area will have broader cloud? This is my cold front, this is my warm front. That is satellite image നോക്കാനാണെങ്കിൽ I am giving you two figures here again. Okay, so this is my warm front and this is my cold front. I'm just giving you two situations. Now what I'm drawing is cloud. Okay, so suppose this is cloud. So please tell me which is correct. Just number it. This is my cloud. This is bigger. That's what I am trying to represent. Sorry, it's very difficult to control it here. Right, so this is a bigger cloud. So here also this is a relatively bigger cloud area, and this is a relatively smaller cloudy area. This is relatively smaller. So please tell me which one is correct. This is first option, this is second option. You are getting a satellite image of clouds. Which is correct? Yes, Neeraj, correct ആണ് പറഞ്ഞത്. But ഞാൻ പറഞ്ഞത് നമ്മൾ മേളിൽ നോക്കുവാണ്, right? It's a satellite image. So അപ്പോൾ നമുക്ക് spread ആണ് കാണുന്നത്, അല്ലാതെ vertically എത്ര വലുതാണല്ലേ കാണുന്നത്. So spread ഏതാണ് correct? Spread, as the other two said, it is 2 is the correct one, no doubt, because it is a warm front. Warm front cloud is more spread. അതുകൊണ്ട് you can see cloud കൂടുതൽ സ്ഥലം വരെ ഇവിടെ കാണും. ഇവിടെ ഒരുപാട് narrow developed cloud ആയിരിക്കും when you see the satellite. That's how they are represented. So I hope these areas are clear. Now please tell me, iduvare clear aano? Iduvare clear allengil it will be difficult for you to understand the temperate cyclone. Do you have any doubt? Enki rendu perude answer kittunnundu, baaki ellare answer kittunnilla. So please everyone can answer this particular thing. Are you clear till this? Yes, we will move further. So rendu front just pettannu ezhuthi vecho. Stationary front, you can draw first thing this figure, and then cold air and warm air just touching with each other, just touching. See, this is my cold air, this is my warm air, not encroaching. There is no arrows, nothing. They're just touching each other. That is your stationary front. And symbol, this is my symbol of stationary front. You can mention this one, nothing else. So you can just mention one line here. Slight cloudiness will be there, but generally no rainfall. Slight cloudiness will be there, but generally no rainfall. Slight cloudiness will be there, but generally no rainfall. കാരണം ഒരുപാട് വലിയ റൈസിംഗ് ഒന്നും ഉണ്ടാവുന്നില്ല, മഴയൊന്നും ഉണ്ടാവില്ല. But ഇതിന്റെ മേളിൽ കിടക്കുന്ന എയർ ചെറിയ രീതിയിലൊക്കെ ക്ലൗഡ് ഫോം ചെയ്യും. There will be no rainfall. That much is enough. No, not more than that. That is my stationary front. Next one is occlusion, occluded front. Fourth type is occluded front. See, I have a better figure. You can take this figure. This is the symbol. Symbol ഇത് വരയ്ക്കാം. Okay. Symbol ഞാൻ രണ്ടാമത് തരാം. This is the symbol. This is the symbol of your occluded front. First you can draw the occluded front. This is the occluded front. That is entire warm air you have to show it as elevated already. Okay. These two figure done. Oh yes, symbol is there. Symbol is here. You can draw it here. Symbol is here. Symbol on the figure on. Now please tell me, will I get rainfall associated with occluded front formation? Occluded front ulla sthalathu will I get rainfall? Yes or no? One is yes. Yes. Then anybody know? Hail onnu illa. Hail ഒരുപാട് strong upliftment ഒരുപാട് മേലെ എത്തുമ്പോഴേ hail ഉള്ളൂ. You will get rainfall, right? Most of you, yes, you have rainfall. Why? Because ഈ കിടക്കുന്ന ക്ലൗഡ് വാം എയർ മേളിൽ കയറിയിട്ടുണ്ട്. ഈ കിടക്കുന്ന ക്ലൗഡ് എല്ലാം കണ്ടൻസ് ആവും, മഴ കണ്ടൻസ് ആയി തീരുന്ന വരെ you will get rainfall. So according to the amount of moisture present in this air, you can get light shower, you can get moderate shower, or you can even get heavy rainfall according to the moisture present in this warm air. So yes, you get rainfall in the occluded front as well. So എന്തൊക്കെയാണ് നമുക്ക് മനസ്സിലായ 4 ഫ്രണ്ട് പഠിച്ചപ്പോൾ എവിടെയാ മഴ കിട്ടാത്തത്? സ്റ്റേഷനറി ഫ്രണ്ടിൽ you don't have rainfall. Rest all the 3 fronts you have rainfall. Hope that is clear. Moving into the topic, that is your temperate cyclones. Temperate cyclones. Okay, so here also first understand, right? Then I will, okay, first you do one thing, just write the stages here, right? Temperate, this is also atmospheric disturbance. Okay, so what is atmospheric disturbance? Normally padikina ellam disturbances, like if I talk about tropical cyclone, it is atmospheric disturbance. If I talk about temperate cyclone, it is atmospheric disturbance. If I talk about tornadoes, it is atmospheric disturbance, right? So all these disturbance, these are atmospheric disturbances, so specifically associated with low pressure systems. Now write down the stages of temperate cyclone, then we will understand. You can then, when I explain, you can link it with the stages. So stages, first stage you can mention stationary front stage. Stationary front stage. First stage is stationary front stage. Second stage, incipient stage അല്ലെങ്കിൽ nascent stage. Incipient stage or nascent stage. Third, mature stage. Mature stage. Fourth, occlusion or dissipation stage. Occlusion or dissipation stage. Occlusion or dissipation stage. Is it okay, everybody, if I extend the class for some time? Some time can be half an hour. Some time can be half an hour. Is it okay, everybody? Because I want to finish this topic today. Any problem, anybody? No problem. Okay. Until issue I would like to finish this entire temperate cyclone. I have to compare tropical as well and temperate cyclone. I have to finish it. Dynamic area time. They are relatively smaller areas. Okay, I will extend, right? So let's go till I finish this temperate and tropical cyclone entirely. Okay, so you have written 4 stages. First is stationary front stage. Second, you have written that incipient or nascent stage. Third one, you have written mature stage. Finally, you have written occlusion or dissipation stage. I hope you already have understood now what is this. ചെറിയ രീതിയിലുള്ള അണ്ടർസ്റ്റാൻഡിങ് വന്നു കാണും. സ്റ്റേഷനറി ഫ്രണ്ട് സ്റ്റേജ് എന്തായിരിക്കും? Remember, 2 fronts, 2 air masses, they just come and they're just coming and touching with each other. Standing here, no disturbances. ഒരു മഴയില്ല, തുടങ്ങാൻ പോകുന്നേ ഉള്ളൂ, രണ്ടും വന്ന് ഇടിച്ച് നിന്നു. Now what happens? If suppose any of them becomes stronger, any of their side, suppose ഒരു cold front, cold air ഇവിടുന്ന് പുഷ് ചെയ്ത് തുടങ്ങിയപ്പോൾ ഡിസ്റ്റർബൻസ് തുടങ്ങി. ഇവിടുന്ന് പുഷ് ചെയ്ത് കഴിഞ്ഞാൽ ഈ സൈഡിൽ നിന്ന് ഡിസ്റ്റർബൻസ് തുടങ്ങും. സോ ദാറ്റ് ഈസ് യുവർ സെക്കൻഡ് സ്റ്റേജ്, നാസൻ സ്റ്റേജ്. എന്താണ്? ആദ്യം നമ്മുടെ സ്റ്റേഷനറി സ്റ്റേജിലായിരുന്നു. ആ സ്റ്റേഷനറി സ്റ്റേജിൽ നിൽക്കുന്ന ഫ്രണ്ട് ഇറ്റ് വിൽ സ്റ്റാർട്ട് ബെൻഡിങ് നൗ. ഇറ്റ് വിൽ സ്റ്റാർട്ട്, രണ്ട് സൈഡും ബെൻഡ് ആവില്ല. കോൾഡ് മേളിലുള്ള എയർ ആണെങ്കിൽ കോൾഡ് എയർ വിൽ സ്റ്റാർട്ട് പുഷിംഗ് ടുവേർഡ് ദിസ് സൈഡ്. ദിസ് ഈസ് യുവർ സ്റ്റാർട്ടിംഗ് സ്റ്റേജ്. ചെറിയൊരു ബെൻഡ് തുടങ്ങും, മിഡിൽ പോർഷനിൽ ലോ പ്രഷർ ഡെവലപ്പ് ചെയ്ത് തുടങ്ങും. ഫൈനലി ഈ കോൾഡ് എയർ വീണ്ടും ഗഷ് ചെയ്യും. കോൾഡ് എയർ പുഷ് ചെയ്യുമ്പോൾ നമ്മുടെ ഇത് ഫ്രണ്ട് കുറച്ചുകൂടെ ഇങ്ങോട്ട് കൂടിപ്പോകും. കുറച്ചുകൂടെ കൂടി പോയി കഴിയുമ്പോൾ ഇറ്റ് വിൽ ബിക്കം യുവർ മെച്യൂർ സ്റ്റേജ്. ഫൈനലി ദിസ് കോൾഡ് ഫ്രണ്ട് വിൽ ഓവർടേക്ക് ദി വാം ഫ്രണ്ട്. എല്ലാ വാം എയറും റൈസ് ആയി പോകും. ആൻഡ് ദാറ്റ് ഈസ് യുവർ ഒക്ലൂഷൻ. ലെറ്റ്സ് ട്രൈ ടു അണ്ടർസ്റ്റാൻഡ് ഇറ്റ്. ക്ലിയർ? സപ്പോസ് ലെറ്റ് മീ ടേക്ക് എ ബെറ്റർ ഫിഗർ ഫസ്റ്റ്. യെസ്, ആദ്യം ഇതിനകത്തൊന്ന് മനസ്സിലാക്കി നോക്കാം. ഇറ്റ്സ് ബെറ്റർ ഇഫ് you can understand it from here. Can I say this first figure is a stationary front? Middle easterlies wind, cold wind blow ചെയ്യുന്ന സ്ഥലത്ത് this can be your polar easterlies. Okay, this is the area where you have your cold air and this is the area where you have warm air. They both are touching with each other. It's a polar front. Polar front ഏതാണ് നിങ്ങൾക്ക് ഓർമ്മയുണ്ടോ? They are mentioning about this area. I'll just show it. This is my equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt. They are explaining this area. They are explaining this area. They are explaining this area. So initial situation it was a straight line. Now they will start twisting them. And the cyclone develop by very. Let's see. Now first initially it's a straight line. So that was what they are explaining. So this is my stationary front. Cold front is above, warm front. Cold air is above, warm air is below. As a result, I am getting a stationary front. Now, because of some density change or extreme cold, the winter season, the polar air will become very cold. As a result of that, it will become stronger. And if that becomes stronger, that what will happen? The cold air will start pushing. You can see here, the cold air will start pushing into the warmer area. Cold air will start pushing into the warmer area. So can you tell me which is the front here? Oh, it is written there, no need to ask, right? So see, you can see cold air is pushing the warm air. So you are getting a development of a cold front in this area. A slight development. So this is your second stage. Our bend. This bend development of kink. K-I-N-K. K-I-N-K means, kink means it is just a bend, right? Simple, a bend or a twist, a curve. Right, or same, just understand any of the word. No need to remember the word kink. What is it? Or twist undava, or curve undava. Edana curve? E curve. Initially it was a straight line, it was a stationary front. Mele tanapayarum, thade chudayarum. But because of more activity from the colder air, the cold air, if it pushes towards the warm air, the line bends, the front bends, which is known as twisting, allangi curving, allangi kink. Clear? Now, if it is bent, what happened is, you can clearly see the air is pushing. So you are getting one front here, cold front. As a result, the entire air gets pushed towards this side. You are getting a warm front in this side as well. So run the front will develop by cold front and warm front. Clear? This is my second stage. Third stage, third stage, better than this particular figure, we can say third stage, what is it? Third stage, even കുറച്ചുകൂടെ കൂടുതൽ സ്റ്റീപ്പർ ആവും. ഇങ്ങനെ കുറച്ച് കൂടുതൽ സ്റ്റീപ്പർ ആവുന്ന ഈ സൈഡിൽ നമ്മൾ കുറച്ച് മുന്നേ വരച്ചേ ഉള്ളൂ. ദിസ് ഈസ് മൈ കോൾഡ് ഫ്രണ്ട്, ദിസ് ഈസ് മൈ കോൾഡ് ഫ്രണ്ട്, ആൻഡ് ദിസ് ഈസ് മൈ വാം ഫ്രണ്ട്. ദിസ് ഈസ് മൈ മെച്യൂർ സ്റ്റേജ് ആണ്. മെച്യൂർ സ്റ്റേജിൽ എന്താ സംഭവിക്കുന്നത്? ഒരു സ്ട്രോങ് റൈസിങ് ഇവിടെ നടക്കുക. ആൻഡ് ക്യാൻ ഐ സേ ദിസ് ഏരിയ, ഇവിടെ എന്താ നടക്കുക? ദി വാം എയർ ഈസ് റൈസിങ് ഫ്രം ദീസ് ഏരിയാസ്. So when I say warm air is rising from these areas, can I say there are low pressure areas developing here? There are low pressure areas developing in these areas. So see, ഇതെല്ലാം ഏരിയ ഇവിടൊക്കെ എയർ റൈസ് ആവുക, ഇവിടുന്ന് എയർ റൈസ് ആവുക, ഇവിടുന്ന് എയർ റൈസ് ആവുക. ഇത്രയും ഏരിയ എയർ ഗ്രാജുവലി വാം എയർ റൈസ് ആവുമ്പം റൈസിംഗ് ഏരിയ യു ഹാവ് സ്റ്റഡീഡ് ഇൻ ക്ലൈമറ്റോളജി ബേസിക്സിൽ wherever the air is rising, those areas are associated with low pressure. So entire these areas the air is rising and you are getting low pressure. And can you see it's a very huge low pressure area? Really കുറച്ച് elongated ആയിരിക്കും. അതുകൊണ്ട് ഈ elongated അല്ലെങ്കിൽ അതുകൊണ്ട് നമുക്ക് such low pressure area, നമുക്ക് tropical cyclone നമ്മൾ പഠിച്ചിരുന്നു. Tropical cyclone നമുക്ക് എങ്ങനെയാണ് low pressure area കിട്ടുക? A small circular low pressure. But ഇവിടുത്തെ low pressure is elongated or elliptical or egg-shaped low pressure. കാരണം ഇതൊരു huge area ആണ് cover ചെയ്യുന്നത്. The entire area is a low pressure area. That's why it is elongated low pressure belts ആണ് നമുക്ക് ഇവിടെ develop ആവുക in this situation. So let me come back here. In this stationary front vannu oru side in the cold air push cheyidu thodangiyappo development of cold front and warm front thodangi, and because of this bending you get a kink, or you can say a twist or a curve, and that area develops relatively low pressure zone, elliptical low pressure develop. Now gradually cold air aduthu varunondirikkundanansarichu warm air mele kerikondirikum. Finally the cold front, as it is faster, it will overtake the warm front. Warm front in overtake egression keri thodangi, what will happen? Entire warm air will move up. Remember occlusion top view aanu kanikkunne. Endana rendu side innu vanna cold air, ee cold air kuda anga meet cheyum. They will become a continuous flat line and the warm air will rise up, and that is my occlusion stage. Ini idakku mala peedu kazhiyumbodathekku cyclone avade igirunnu. So this entire phase is known as cyclone. Ivada cyclone thodangi. These 2 and 3 can be set as a maturing stage, and finally you can say dissipating stage. So let's see. Sorry. This one is stationary front stage. This second stage we can say it is your that what is that? Initial nascent stage. Third stage we can say is your mature stage, and the fourth stage is dissipation stage. Now try to understand in another ways. Clear? Yes. See it with this figure now. This is the area. North America cyclones temperate cyclones, temperate areas. So initially it was a stationary front, it was a straight line. See, kinking bend or curvature. That is your development of cold front. You can see here development of cold front and warm front. As a result, low pressure. Now cold front is faster. So cold front is faster means entire area is getting closed up gradually. Finally, warm area cold air in two sides gets mixed together and the front dissipates in this area. Let me show you another figure. You can see this one. See, same thing. In this area, this was our cold front. Isn't the figure? Yes, this one is the best figure. You can see this was the cold front we have seen earlier. So even the cold air pushing, this was the warm front. So warm air is in pushing. This is my warm front. As this is faster, this area will gradually come towards this side and they will close together. As a result, close eye cream and the entire warm air moves up and the front dissipates. That is my occlusion in that area. Let's try to see other figures. Now, the difficulty slide it around. This is simple, my cold front and warm front. Yes, see, you can explain it with the front itself. So these are first thing. This is my the straight line iron stationary front. Bend eye thodangi, kinking. Cold air mass strong eye. So cold front strong eye to push in. Cold front push in. This is a cyclonic stage. If low pressure your entire air system is rotating. Why this air system is rotating? Because these air masses are interacting. As a result, and you have Coriolis force. The air masses, the entire air system is rotating. And please remember, if I show you, if you remember, the tropical cyclone, it was a localized low pressure. But temperate cyclone, it covers a huge area. That's why you get elliptical shape. Now, please tell me which will be stronger. Stronger ways means with respect to force, with respect to speed, which is stronger. This is tropical one. Which will be stronger? This is tropical one. This is temperate one. So please tell me which will be stronger with respect to intensity, strength. Good, fine. Yes, good, very good. Tropical. Reason is there is strong low pressure. Convectional heating strong low pressure. Heating dynamically air is. If you remember our pressure belts we have seen thermally induced pressure belts, dynamically induced pressure belts, and we have seen thermally induced belts are very strong. Here it was thermally induced tropical cyclone, so it is very strong low pressure. Here it is dynamically induced. Dynamically induced air ne push the melo to get. What is dynamically induced? It is clearly because of temperature difference. So the dynamically induced pressure belts are not that strong. So here, strong wind cyclone it can reach generally super cyclones velocity but ideally more than 100 km/h carrying like a crazy. Here it generally reaches up to around 60 km/h. That is the velocity of this temperate cyclones. That is not that much stronger as compared to our tropical cyclones. So that difference you have to understand. So here, first stage front straight stationary front. Second stage push cold air bend on die. That is my second stage or nascent stage. Low pressure develop. Now the cold air, if it pushes more faster, the entire fronts will start bending, entire curvature will start, entire air will start moving according to the Coriolis deflection, that is clockwise direction move here, northern hemisphere. Strong low pressure develop 60 km/h speed like a wind blows and gradually this cold air mass, cold front will move towards this side and entirely it will cross the warm front, leading to the occlusion. So occlusion this one. The cold air is pushing, gradually it will enter, this entire warm air will rise, and this cool air and cold air under temperature what will difference varilla. So they will just mix together and that front dissipates. That is your occlusion. So these are cyclones. These are temperate cyclones. It's clear on that is a front clear iron. The understanding of temperate cyclone is very easy. So please tell me, is that clear or shall I repeat? Anybody who is not clear? So we can I can repeat, no issue. Fine. Okay. So please, you understand temperate cyclone മനസ്സിലാക്കാൻ ഒരു കാര്യമേ ഉള്ളൂ. You have to understand different types of front. Cold front എന്താ, warm front എന്താ, stationary front എന്താ, occluded front എന്താണ്. ആ 4 type of front മനസ്സിലാക്കണം ആയി കഴിഞ്ഞാൽ you just have to arrange it. How? Which one starts? It starts from the stationary front. അത് കഴിഞ്ഞാൽ എങ്ങോട്ടാണ് പോവുക? സ്റ്റേഷനറി ഫ്രണ്ടിൽ നിന്ന് ചെറിയ രീതിയിൽ ബെൻഡ് ആയി തുടങ്ങും. That is, you have the generation of cold front and warm front. In that cold front, you have to understand cold front is more stronger. When I say cold front is more stronger, it will continuously keep on pushing the warm air and try to overtake the area where you have the warm front. And when it overtakes, entire warm air gets uplifted, and that is your next stage, final stage, that is known as occlusion. In between, you have mature stage. So you have occlusion. Occlusion I കഴിഞ്ഞ cyclone avade dissipate ആവാൻ പോവാം. That's how cyclone gradually gets dissipated. So starts with stationary stage, കുറച്ച് ഒന്ന് bend തുടങ്ങും, that is kink or a bend, then gradually it becomes matures, then finally you have occlusion. That is your 4 different stages of development of temperate cyclones. Is that clear? You need to write something, or is the figure and explanation is okay? Dictate ചെയ്യേണ്ട കാര്യം ഉണ്ടോ അതിനകത്ത്? I hope it is simple right now. 4 front നിങ്ങൾ എഴുതിയിട്ടുണ്ട്. You can just match them up and write, and add figure and symbols you can write. Do I need to dictate? It's up to you. You can tell me. If you need, I can dictate. ഒരുപാടൊന്നും ഇല്ല അതിനകത്ത് പ്രത്യേകിച്ച് പറയാൻ. You just have to dictate. ഞാൻ ഒരു ഫിഗർ വരച്ച് കാണിച്ച് ഓർമ്മയുണ്ടോ? I hope you remember this one. Cold front, warm front, cloud. Remember this figure? This figure, if you have to draw to explain cyclone, temperate cyclone, please tell me you arrange in which stage? First stage, second stage, third stage, or fourth stage? Either stage of cyclone like you figure കാണിക്കാൻ പറ്റുമോ നിങ്ങൾക്ക്? If you want to explain this figure, associate this figure with the cyclones. And answer I want rest of you to answer. There are somewhere around 30 in the group. Hari fourth ഒരിക്കലും ഉണ്ടാവില്ല. Fourth എന്താ? Dissipation ആണ്. Fourth occlusion ആണ്. There is no front. Almost full front is getting dissipated. ഇവിടെ നിങ്ങൾക്ക് clearly cold front warm front കാണാം. So not possible. Fourth stage is not possible. So majority you are correct, right? It is your third stage, that is mature stage. Amrita second stage എങ്ങനെ വരുക? Second stage just ഒന്ന് bend ആയി തുടങ്ങുന്നേ ഉള്ളൂ. So അത്രയും strong cloud formation ഒന്നും തുടങ്ങിയിട്ടില്ല. Third stage ആകുമ്പോഴത്തേക്കാണ് strong cloud formation കാര്യങ്ങളൊക്കെ അവിടെ ഉണ്ടാവും. Clear? It is third stage or mature stage. അവിടെയാണ് ഈ ഒരു conditions you can associate with. Clear? So this is my temperate cyclone. Shall I come? Okay, one more thing. Now, if I ask you, is this everything regarding temperate cyclone? I can say, no, there is something more. What is that something more? See, the cyclones, temperate cyclones are relatively a dynamic concept, right? You cannot, it's not that easy, right? കാരണം ഈ ഗ്രൗണ്ടിൽ നടക്കുന്ന കാര്യങ്ങൾ മാത്രമല്ല അതിനെ അസോസിയേറ്റ് ചെയ്യുന്നത്. ഇതുവരെ നമ്മൾ പഠിച്ചത് these are the conditions which is happening on the ground. What is that condition? You have different types of air masses that is interacting. This is happening in the ground level or just above the ground level. Yeah. So as a result, you are getting this temperate cyclone. Please remember, temperate cyclones are also formed or are also associated with higher altitudinal winds. What is higher altitudinal wind? We can take the example of jet stream. We have not covered jet stream. We are going to do it in the next class. Jet stream also this affects the cyclone. Allengil I can say jet stream also plays a role in initiation of a cyclone. Just try to understand it vaguely. Concept ipa manasilaakanda. Next class jet stream manasilayi kayumba concept will be clear. So for example, suppose this is a ground level. Idinte melathe air suppose maybe around 10-15 kilometers above, 10-15 annum kottanda 8-10 kilometers above, suppose you are experiencing a jet stream. Now please remember the condition. The jet stream is a property under, and that property is known as meandering. You know the meandering of a river. So suppose this is a river that is meandering. Similarly, jet stream also meanders. Jet stream meandering in inganella. Jet stream, if this is my earth, jet stream moves along the parallel to the latitude. So it meanders like this. Clear? So here suppose a river is moving in this direction, and we have studied meandering. We have studied that this outer side of the river, the velocity is very high. Inner side of a river, the velocity is slower. I hope you remember that particular thing. As a result of this, can I say when velocity becomes suddenly faster in this area. ഈ ലൊക്കേഷനിൽ കുറെ കൂടുതൽ എയർ വന്ന് ഗഷ് ചെയ്ത് ഈ ഏരിയയിലോട്ട് കയറും. ഈ ഏരിയയിലോട്ട് huge air gushes into this area, it enters into this area. As a result, this area, if you compare this jet stream with meander, ഇവിടുത്തെ river velocity കൂടുവാണ്. ഇവിടെ river വന്ന് collide air this water എല്ലാം കൂടെ വന്ന് hit ചെയ്യുവാണ്. Similarly, in the case of wind, can I say wind is coming into this area very fastly. That is, this is a convergence area, right? ഇത്രയും സ്ട്രോങ് ആയിട്ട് വിൻഡ് വന്ന് കയറുവാണ് ഇൻ ഏരിയ. സോ കൺവേർജൻസ് ഏരിയാസ് എന്താണ്? കൺവേർജൻസ് ഏരിയാസ് ആർ ബേസിക്കലി ലോ പ്രഷർ ഏരിയ. ഓർ അതേപോലെ ഇറങ്ങിപ്പോകുന്ന ഏരിയ, ഈ ഏരിയ നോക്കുമ്പോൾ ഇത് ഇറങ്ങിപ്പോവാണ്, ഇറ്റ് വിൽ ക്രിയേറ്റ് സർട്ടൻ ഹൈ പ്രഷർ. സോ സിമിലർലി വെലോസിറ്റി മാറുന്ന പോലെ മിയാൻഡറിൽ, this concept I will explain it better when you study jet stream. Please remember, when jet stream passes through an area, it creates alternate low pressures and high pressures at different areas. Clear? ഇത് എവിടുത്തെ കാര്യം നമ്മൾ പറയുന്നത്? upper air circulation upper atmosphere it creates low pressure and high pressure. Now please remember, we have studied somewhere, suppose it is a low pressure on the ground, it will be high pressure over it. Remember, because air will converge here. Similarly, if it is a high pressure here, it will be low pressure above it. Karna ivadte air aanu ingotu vannu veedune, so you get low pressure. So every low pressure on the ground surface has a high pressure above. Similarly, every high pressure on the ground has a low pressure above. We have studied this particular thing. Similarly, every high pressure on the upper air circulation will have a low pressure. Opposite also is true. I will have a low pressure on the ground. Every low pressure developed on the higher surface will develop a high pressure on the ground. That means എന്താണ് ഇവിടെ ഞാൻ പറഞ്ഞു വരുന്നത്, ഈ jet stream high altitude ലൂടെ blow ചെയ്യുമ്പം it creates alternate high pressure and low pressure in the upper atmosphere. This is my ground. Upper atmosphere, this is my ground. Suppose this is my upper atmosphere through which jet stream flows. The upper atmosphere it creates alternative high pressure, low pressure, high pressure, low pressure. Jet stream it keeps on creating this on the higher surface. So if it is creating a high pressure here, when I say this is anticyclonic, just below that it will create low pressure, that is cyclonic condition, right? If it creates a low pressure, below it it will create anticyclonic conditions on the ground. So please remember, jet stream melinu flow cheyavanengilum lower surface ne also it affects. If jet stream the path high pressure undengil, it creates low pressure on the low surface, and this low pressure can result into cyclonic developments. So please remember, frontal interaction is one of the reason. Adu matram ningal details padicha madi. Idu onnu aranjirikkuva. Jet stream the formations can also lead to development or continuation or modification of temperate cyclone. Just have to understand it, not more than that. This is much more than needed. So please understand, these jet streams also affects these temperate cyclones. Jet streams we will study in details in the next class. We will understand more. Please, this much area you have to remember. Jet stream also affects temperate cyclone. Is that clear? This was the slide. See, you can see somewhere here. Can you see it was a high pressure in this area? So when it is a high pressure in this area, below here somewhere it will create low pressure. Low pressure ന്റെ താഴെ എവിടെയും high pressure. ആ ഒരു ഡിഫറൻസ് ഇവിടെയും ക്രിയേറ്റ് ആയിക്കൊണ്ടേയിരിക്കും jet stream മൂവ് ചെയ്യുമ്പോൾ. So it creates this different low pressure, high pressure. On jet stream can impart high pressure and low pressure on the surface. Clear? You can see ഇവിടെ air descend ചെയ്യുമ്പോൾ high pressure, ഇവിടെ air rise ചെയ്യുമ്പോൾ low pressure. This low pressure can result into cyclonic movements. So please just have an understanding. Jet stream also have effect in this particular thing. Clear? Remember this much. So if this much is clear, I will directly move into the difference between tropical cyclone and temperate cyclone. You have to write it. So is there clear up to now? Do you need to write anything else, or shall we directly move into differences? Okay, now it's clear. So heading differences between tropical and temperate cyclones, and keep writing. Column first column tropical cyclone, second column temperate cyclone. First column tropical cyclone, second column temperate cyclone. So first column tropical cyclone, it originate and grow in tropical zone. It originate, whichever point do you need further explanation, I will keep explaining. So this point on explanation, you know that it originates and grow in tropical zone. Other column, temperate cyclone. Temperate cyclone is also known as extratropical cyclone. Okay, extratropical cyclone. No, so temperate cyclone originates and grows in temperate zone. Second point, tropical area. It mainly originates in sea. It mainly originates in sea and generally disappear after crossing over to the land, and gradually disappear after crossing over to land, and gradually disappear after crossing over to land. Temperate cyclone upper the side, it can develop both over the land and sea. It can develop both over the land and sea. I hope it's clear why. And the tropical cyclone and excessive heating of sea surface temperature was the main reason. That's why it originates in the sea. Continuous moisture supply even air mass interaction. That's land there is no such proof. Clear? That is it. Next point. Tropical cyclone. It is more active in summer. Tropical cyclone. It is more active in summer. And temperate cyclone directly opposite. It is more active in winter. It is more active in winter. Yes or no? Because winter cold front strong. Cold front strong, it will push faster. It will lift the warm air faster. That's why it happens more in summer. Sorry, winter. Temperate cyclone. So temperate cyclone winter, tropical cyclone summer. Next, isobars are circular in tropical cyclone. Localized circular cells. Isobars are circular in tropical cyclones, and they are elliptical in temperate cyclones. They are elliptical. It's elongated, elliptical shape, egg shape. They are elliptical in the temperate cyclones. Next, diameter of the cyclone is relatively smaller. Tropical cyclone. It's a localized, very strong low pressure. So strong. Diameter is relatively smaller. Maybe 5 square kilometer to 100 square kilometer. 5 square kilometer to 100 square kilometer area cover. Upper the side, you can mention very large. Diameter can be 800 to 1800 kilometers. Size can be very diameter and the size it can be very large. 800 to 1800 square kilometers. So tropical cyclone area cover somewhere around 5 to 100 square kilometer. Temperate cyclone 800 to 1800 square kilometers. Next point, tropical cyclone. It has very steep pressure gradient. It has very steep pressure gradient. Pressure gradient strong because temperature is the reason, thermal reason. Steep pressure gradient. Temperate side gentle pressure gradient. Relatively gentle pressure gradient. Relatively gentle pressure gradient. 7. Next point. Wind velocity is very high. Tropical cyclone. Wind velocity is very high. Can be more than 100, 150, even crosses 200 kilometers per hour. Wind velocity is very high. Tropical cyclone. Upper the temperate cyclone, wind velocity is relatively less. Wind velocity is relatively less. Average you can mention somewhere around 70 kilometers per hour. Somewhere around 70 kilometers per hour. Tropical cyclone. It is associated with torrential rainfall confined to a smaller area. Tropical cyclone associated with torrential rainfall confined to a smaller area. Torrential rainfall confined to a smaller area. Temperate cyclone, light rainfall and widespread area. Light rainfall and widespread area. Tropical rainfall stops in few hours. We have mentioned that land it gradually weak, it becomes weak, right? So bracket land on land, rainfall stops in few hours. A particular area gradually slow it stops weeks in few hours. Temperately you can mention it continues for several days, 6, 7, 8 days or a continuous rainfall it continues for several days. Next, tropical, it moves from east to west generally. It moves from east to west generally. Generally mention because low pressure condition generally it moves from east to west. Upper the side it moves from west to east. It's almost always. Temperate side it moves from west to east. Anybody tell me why? What is the reason that tropical cyclone moves from east to west while temperate cyclone has a tendency to move from west to east? What can be the reason? I need the answer. Yes. So westerlies effect westerlies നിൽക്കുന്ന സ്ഥലത്താണ് നമുക്ക് westerlies wind ഉള്ള സ്ഥലത്താണ് temperate cyclone ഉണ്ടാവുക. So it moves from west to east with the effect of westerlies. Tropical cyclone എവിടെ ഉണ്ടാവുക? Tropical area. So it comes under the effect of easterlies. So it moves towards east to west. That is the reason. Next point. Temperature is first point. Tropical cyclone. Temperature is more or less uniform throughout the cyclone. Temperature is more or less uniform throughout the cyclone. Yes, I mentioned that island area variations കാണും, but still ഒരുപാട് വലിയ variations ഇല്ല. More or less entire cyclonic area temperature is relatively same. അപ്പുറത്തെ സൈഡിൽ same ആയിരിക്കുമോ? It is never possible, right? It will be different because രണ്ട് different types of air mass ആണ് interact ചെയ്യുന്നത്. So cold air mass ഉള്ള സ്ഥലത്ത് temperature will be cold, warm air mass നിൽക്കുന്ന സ്ഥലത്ത് temperature will be warmer. So write down temperature will be different in colder and warmer sections. Temperate side temperature will be different in colder and warmer sections. Temperature is colder in different in colder and warmer sections. Next point, tropical cyclone. Energy of cyclone is derived from latent heat of condensation. I have explained that. Energy of cyclone is derived from latent heat of condensation. Upper side energy is derived from frontal activities. Upper side energy is derived from frontal activities. You know that energy is derived from frontal activities. So these are main differences. Let me check anything is missed. Okay, you have written the shape of isobars, right? Yes, you have written that. Size you have written. You can also mention about destruction. Either more destructive. You can write it, right? Tropical cyclone is highly destructive. Material destruction illa. After destruction corona temperate cyclone, just you get continuous rainfall. That's it. Enough. That is it. These are the differences. So we are done with the entire area, that is dynamic area. The entire cyclones we have completed: tropical cyclone and temperate cyclone. So please go through the notes. Today's class in the air masses and this front interaction, cyclones and differences. Tell me if you have any doubts. We will find it out. Cloud formation we are doubt to cloud formation see tropical cyclone you get extensive cumulonimbus cloud forms in, right? And you get very strong thunderstorms can come in between, right? Tropical cyclone. Temperate cyclone you get both. That is warm front you are getting stratus cloud, while cold front you are getting your cumulonimbus cloud. But please remember, if you compare the strength and this heaviness of the cloud and the density of the cloud, no doubt it is tropical cyclone. Tropical cyclone is a dense cloud. Temperate cyclone is a strong dense cloud. If I compare among the cumulonimbus, then also our cumulonimbus cloud, our cumulonimbus cloud is strong generally.